Finally, let's talk about some ways that we can describe how spread out a data set is, some measures of variation. So we're going to discuss a couple different ways to describe the spread of a data set. We'll start by talking about quartiles. And quartiles are values that divide the data set into quarters. The first quartile, which I'm going to abbreviate as Q1, is the value such that 25% of the data is below it. And the third quartile, Q3, is the value such that 50% of the data is below it. The second quartile is technically our median. So basically, we're dividing the data into fourths, with a Q1 being the first quarter, the median is 2 quarters, and Q3 is 3 quarters. So I've got a bunch of information on this slide about how we find quartiles, but I think it is going to be easiest if I just show you with an example. Although I'll run through this really quickly. This is basically saying, so just like with the median, you have to organize the data from smallest to largest. And just like we did with the median, we can compute a locator. If we're doing the first quartile, we want to know where is the first 25% of the data. So we compute 0.25 times n, where n is our number of data points. And then we have the same rules. If we get a decimal, we're going to round up. And if we get a whole number, we're going to take the average of 2 values. If we want to find the third quartile, our locator becomes 0.75 n, because we're trying to figure out where is 75% of the data below. So let me just do an example. I think this will make much more sense with an example. So I've got 2 different data sets. We'll start with data set A. These values are already in order from smallest to largest. That's good. And then I can just count how many are there. There are 7. 3, 4, 5, 6. Yep, 7 data points. So my first locator, I take 0.25 times 7, and I got 1.75. The rule is anytime you get a decimal, no matter what that decimal is, you round up to 2 in this case. And so the second value, 1, 2, yep, the second value is 5. So Q1, my first quartile, is 5. To find the third quartile, my locator is going to be 0.75 times n. N was 7. So 0.75 times 7 is 5.25. And the rule is it doesn't matter what the decimal is. Anytime there's a decimal, you round up. And so the sixth value, 1, 2, 3, 4, 5, sixth value is 9. Q3 is 9. Locators are really helpful when we have large data sets, but another way of thinking about this, what we're technically doing here is, you can think of it as we're cutting our data set in half, and then we're finding the median of the bottom half and the median of the top half. That's technically what our quartiles are. All right, let's do part B. So this time I did have to reorganize the data so it was listed from smallest to largest. So I put the numbers in order, 3, 4, 5, 6, 7, 8, 10, and 20. And there are 8 different numbers listed, so n is 8. So for Q1, my locator is going to be 0.25 times 8. That is 2. Because I got a whole number, I'm going to take the average of the second and the third values. So anytime you get a whole number, you'll be taking an average. So second and third values are 4 and 5. The average of 4 and 5, 4 plus 5 divided by 2, is 4.5. So there's Q1. Q3, my locator is 0.75 times 8. That's 6. I got a whole number again. So I'm going to take the average of the 6th and the 7th values. So that was 8 and 10. When I average 8 and 10, I get 9. So Q3 there is 9. Now, we use quartiles when we create what's known as a 5-number summary, and we can visualize a 5-number summary using a box plot. So the 5-number summary of a data set consists of the minimum, the smallest value, the first quartile, the median, the third quartile, and the maximum. So those 5 numbers are considered the 5-number summary of a data set. And we can visualize this by drawing what's called a box plot or a box and whiskers plot. By drawing a box, the box always goes from Q1 to Q3, so that's the box part. And then we put a line in it where the median is. And then we draw these 2 whiskers that extend out to the minimum and the maximum value. So let's try to create a box and whiskers plot for the following data set. So I've got a bunch of values, those are my numbers, and then I've got their frequencies, number of times that they occur. So if I want to draw a box and whiskers plot, I have to find my 5-number summary first. So the minimum and the maximum I can just read right off of the table. So I'm reading off of the values. The smallest value in this data set is 9, that's my min. Largest is 17, that's my max. So got the min and the max. And then to find my quartiles and my median, I do have to know the number of data points, and then I'll be able to compute those locators. So to get the number of data points, the n, I have to add up all the frequencies. So I took 3 plus 5 plus 7 plus 12 plus 10 plus 11 plus 4 plus 1 plus 2, added up all those frequencies, and I got 55. So there are 55 values in this data set. So let's do the median first. To find the median, our locator is 0.5 times n. So 0.5 times 55, that's 27.5. It's a decimal, so we round up. It's the 28th value. Now I do have to figure out where in this table is my 28th value. So I'm going to look at the frequencies. The first 3, so 1, 2, and 3 are 9s. And then the next 5 are 10s. And so what I did is I said, so I stopped at 3 here. 3 plus 5 is 8. So 4 through 8 is in the next row. And then 8 plus 7 more is 15. So 9 through 15 is in the third row. And I'm just going to fill out the whole table right now. So 15 plus 12 is 27. So data values 16 through 27 are here. And then I just did the rest of them. So 27 plus 10 gave me 37. So data values 28 through 37 are 13. 37 plus 11 is 48. 48 plus 4 is 52. And there's only one value of 16, so that's the 53rd value. And then 2 values of 17, that's 54, 55. Oh, that's nice that I stopped at 55. That tells me I probably didn't make a mistake because there were 55 data values in this set. Okay, so back to what we're doing. We're trying to find the median. Our locator is 28. The 28th value is in this column I've circled, or this row I've circled in pink. It has a value of 18. No, I said that wrong. I wrote it down right at least. It has a value of 13. So my median is 13. Okay, middle value is 13. Now let's find our quartiles. Q1, for the locator, we're going to do 0.25 times 55. I got 13.75. Again, it's a decimal, so we round up. So 14th value is Q1. And so this is where all these numbers are going to help me. Where is the 14th? Oh, right here in 9 through 15. So the 14th data point has a value of 11. Q1 is 11. And then finally for Q3, I do 0.75 times 55. We always round up. So I got 41.25. I round that up to 42. And there we go, 42, or the 42nd value is 14. So there's my Q3. Finally, I'm going to draw all of this into a box and whiskers plot. So I just jotted down again the numbers that I've already computed. So my min was 9, max was 17, median is 13, Q1 is 11, Q3 is 14. All right, and so when we create our box and whiskers plot, I would like you to include some type of scale. Without any type of scale, it's not really going to mean anything. So we need to include kind of a number line on the bottom. And then we'll draw our box will go from Q1 to Q3. So I'm going to have my box go from 11 to 14. So look at my tick marks. There's my box. And then the whiskers extend down to the min, which is 9, and up to the max, which is 17. And then I'll put a line in the middle where the median is, and that was 13. And so there's my box plot. So box plot is one way to kind of visualize the sum of the spread in that data set. There's another number that we can use to illustrate the spread of a data set. And I'm going to show you what that number is by doing an example. So let's consider two different data sets. We'll say a company is testing the life of two different batteries. Their results in hours are the following. So battery A has a life of 40 hours, 80 hours, 100, 120, or 160. And then battery B, the times they got in testing were 97, 98, 100, 102, and 103. So if we were to compute the mean and the median of both of these data sets, it turns out they're the same. So first data set, if you add up all the values and divide by 5, you get 100. And the middle number is also 100. And it turns out if you do the same with battery B, add up the numbers, divide by 5, you also get 100. And the middle value is 100 as well. So if we just look at the mean and the median for these data sets, they look really similar. They both are 100 hours. However, we can tell by looking at these numbers that they're very different. I would say that battery A has very variable times, where battery B is much more consistent. And so we have a statistic that can actually measure that information or give us information about how variable or how consistent the values are. And that is called our standard deviation. Standard deviation is a measure of variation. And I'm going to show you how to compute it by doing an example. But a couple of quick facts. When you compute standard deviation, it will always be positive. You get 0 if the numbers are all the same. And the more spread out the data set is, the larger your standard deviation is. Okay, so if standard deviation is large, it just means your data set is spread out. Standard deviation has the same units as the original data. And just like when you're computing means, if there is an outlier, it definitely can influence your standard deviation. So a couple quick facts. So to compute the standard deviation, I have some ugly looking formulas on the screen. But basically what we're going to do is we are going to start by finding, it says the deviation of each data value from the mean. So that means we're going to take each data value, which I'm calling x, and we're going to subtract the mean from it. So we're going to take our data point minus the mean. That's step 1. And then after we do that, step 2, we are going to square the result. Then we are going to add up all the squared deviations. That's what this sigma stands for. It means add up. So we're going to add up all those squared deviations. Most of the examples we're going to divide by n minus 1, where n is the number of data points. And then finally, we are going to take the square root of everything. So I know this is a complicated process. I am going to definitely do an example, and hopefully that'll explain how the process works a little bit better than this kind of ugly formula. I should mention there are two different formulas on the screen, though. We actually just divide by n if our data set represents a whole population, or like data from a census. So if our data set describes everybody that we want to understand, we would just divide by n. But if our data set comes from a sample, just a select group, it turns out we have to divide by n minus 1. All right, so let's go back to our two different batteries, and let's see if we can compute the standard deviation of each. So the first thing you're going to do in any standard deviation computation is find the mean. And I already did that. I found the mean. It was 100. Now, I would say both of these are samples because they didn't test all of their batteries. They just picked 5 to test. So we are going to use that sample standard deviation formula and divide by n minus 1. I think most of the time that's the formula you're going to use. So we'll start with battery A, and I usually like to do my work in a table. It just helps me stay organized. So I'm going to start by listing, I'm going to call it X, all of the numbers in my data set. So 40, 80, 100, 120, 60. So I list all the numbers in my data set, and then the next thing I have to do is take each of those values minus the mean. So the difference from the value and the mean. We computed earlier that the mean or the average of this data set is 100. So for each of these x's, I'm going to do x minus the mean. So 40 minus 100 is negative 60. And then I'm just going to go through and do that for the rest of them. 80 minus 100 is negative 20. 100 minus 100 is 0. 120 minus 100 is 20. 160 minus 100 is 60. Okay, so we find our deviations from the mean. That's the x minus m. And then we square it. So we're going to take each of those numbers and square them. So negative 60 squared. If you are going to use a calculator, you need parentheses. Because we're squaring that entire number. We're taking negative 60 times negative 60. That should give us a positive. When you do the squaring, you should always get positives. So negative 60 times negative 60 is 3,600. And then I went through and did the rest of them. 20 squared gave me 400. 0 squared was 0, etc. So I did all those squares. All right, so we did the subtraction, the squares. The next step is the sum. So then we have to add up all those squares. 3,600 plus 400 plus 0 plus 400 plus 3,600. I got 8,000 when I added them up. Finally, almost done. 2 more steps. N is 5. There are 5 data points in this set. So n minus 1 is 4. So I'm going to take my sum, which was 8,000, divided by 4. I get 2,000. And then finally, I take the square root of 2,000. And there's my standard deviation, 44.72 hours. And so we'll definitely talk more about standard deviation and how we can interpret it in a future chapter. But for now, this is a number that's just telling me how spread out is the data set. I think standard deviation is most useful when we compare it. So if we want to do the same thing for battery B, we'll be able to make a comparison. So mean was also 100. So I'm going to start by doing x minus 100, x minus the mean for each of those numbers in that data set. So 97 minus 100 was negative 3, etc. I wrote down the rest of them. Then we're going to take our x minus the mean and square them. So negative 3 squared was 9, negative 2 squared is 4, 0 squared is 0, 2 squared is 4, 3 squared is 9. So I did all my squares. Next step is to find the sum. So I'm going to take all of those numbers in that last column, 9 plus 4 plus 0 plus 4 plus 9. Add them up and I got 26. We still have 5 data points, so the n minus 1 is 4. N was 5, n minus 1 is 4. 26 divided by 4 is 6.5. Finally, we take the square root of 6.5, and there's my standard deviation, 2.55 hours. So notice that battery A had a much larger standard deviation than battery B, and that's just because battery A has numbers that are much more spread out than battery B. I'm going to stop there. Please let me know if you have any questions on this video.